All right, in this video I'm going to go through each of the questions here on our exam review kind of quickly. I may spend a little bit more time in areas where I know that we've been struggling. If you only want to look at a certain part of this, then just fast forward to that part, but this probably is going to be a little bit longer. So in problem 1, we're trying to find that value of x, right? Solve for the variable. So in this case, I've got 0.7x, which means 0.7 times x. So if we divide by 0.7, we do that on both sides, you will get x equals 5. Number 2, trying to get x by itself, we have to first get rid of this plus 33 and then get rid of the 5. Remember, we do this by doing opposite operations. So since I've got plus 33, if I subtract 33, that will go away. If I do it to one side of the equal sign, I have to do it to the other side of the equal sign. That's what keeps everything balanced. So then we end up with 5x equals 52 minus 33, which is 19. We divide both sides by 5. That's our final step to get that x by itself. And we're going to get a decimal answer. 19 divided by 5 is 3.8. Next, we've got some extra stuff going on here. We're going to want to distribute this -8, and then it looks like we're probably going to have to combine some like terms before we are able to get x by itself. So -8x, -8 times 1 is a -8. So instead of writing plus -8, that's the same as -8. -16 equals 135. Now the terms I can combine are a -8 and a -16 because they're just numbers. So -8 minus 24 equals 135. Add 24 to both sides. And I just realized I lost an x up here. So we've got -8x equals 159. Something about that just doesn't look right to me, but let's keep going. Actually, I'm going to go back here and check my work a little bit. Distribute -8, -8, -16, minus 24. Yep, looks good. Divide by -8, and you would get x equals -19.875. Next, we're looking at an absolute value problem. We need to get this down to just the absolute value part, and then we're going to have to split that into two equations. So -4 from both sides, so that we've got absolute value of 2x plus 5 equals 13. And now that we've got it down to just the absolute value, we're going to need to split this into two equations. So either 2x plus 5 equals 13, or 2x plus 5 equals -13. And it's going to be the same two steps, same two steps, which would be -5 from both sides. I'm just going to do these both together. So 2x equals 13 minus 5 is 8, or 2x equals -18. Divide both sides by 2. In each of those equations, you'll get x equals 4, or x equals -9. And both of those are solutions. And the reason, remember, what absolute values does is it makes the quantity inside positive. Whatever it is, think of it as a distance from 0, and we're going to make that value positive. So if x equals 4, we plug this in, make that number positive, add 4, we'll get 17. Same thing if x equals -9, plug that in here, make it positive, add 4, we'll get 17. And actually going through that process would be a really good way to check your work here. Number 5, determine how many solutions it has. So we're going to want to just simplify everything here and then see what we get. We'll talk about those solutions in a minute. So let's do our distribution first on both sides, and then it looks like we'll be able to combine some like terms. So -4x plus 24 minus 4 minus x, negative 2x, plus 20 minus 3x. So let's see. I'm going to kind of do this all in one here. I've got x values, which would combine to make negative 5x. And then this would be plus 20, so negative 5x plus 20. On the right, also negative 5x plus 20. So now think about, we could do this, or you could probably just think about what would happen if I add 5x to both sides. Both of these terms are going to go away. If I subtract 20 from both sides, both of these terms are going to go away. So really what we would end up with is 0 equals 0. They're exactly the same. And so what this tells us is that there are infinitely many solutions. Remember, when the variables all cancel out and we end up with something that's true, that is infinitely many. If we end up with something that's not true, that is 0 solutions. Or if we just get x equals a number, that's our normal 1 solution. Next, we solved the following equation and found this as our solution. Check your solution. So if we're checking a solution, we're just going to plug that value of x in for x and see if we get something that's true or not. If it's true, then it is a solution. If it's not, it's not. So 1/2 times negative 16 plus 4, negative 16 over 4. And remember, what absolute value does is make everything positive. So what I'm noticing right now is that on the right side of this, I have a negative number. Negative 16 divided by 4 is negative 4. And it doesn't matter what's inside this absolute value. There's no way that when I take the absolute value, it can equal a negative number. So we know that negative 16 is not a possible solution. Moving on, we have a ratio problem. Okay, so we're trying to find that value of y. And this is really just a one-step equation, right? I've got y divided by 5. So to get the value of y, I'm going to add 5 to both sides. The thing we need to remember with proportions is that if this were flipped, so 12 over 108 equals 5 over y, both of these proportions would end up equaling the same thing. The one you've been given is really nice because the variable's on top. That just makes it a one-step problem. But this means the same thing. We could flip both sides if we wanted to. So if we multiply both sides by 5, it's going to give us just y on the right, and on the left we'll need to do, and let me just write it out, 5 times 108 divided by 12. And we get 45. Next, we have another one of these problems where we just are going to need to set up these ratios ourselves. So we have a car that traveled this many miles in this many hours. Car B traveled this many miles in this many hours. So we're looking for the greater speed in miles per hour. So car A traveled 185 miles in 2.5 hours. So if we just do that division, 185 divided by 2.5, that will tell us how many miles per hour they were traveling on average. So 74 miles per hour. And then we just do the same thing for car B. So this would be 207 divided by 2.8 miles per hour. 207 divided by 2.8 is 73.92. Going to squeeze this in here a little bit. So notice car A was slightly faster at 74 miles per hour. So car A is faster. All right, moving on to number 9, solving for y. So these are those literal equations where we're going to be solving for one of the particular variables. So in this case, we're solving for y. We need to get this equation in the form y equals something. So remember, we can treat all of these other terms, right? So like this is a term and this is a term. We can treat those just like numbers, even if they are letters. Like in the second one, those are just all variables. So I'm going to try to get everything away from y. So I got to get rid of that 2. I got to get rid of this negative 10x. So first thing we want to do, add 10x to both sides. Get 2y equals 5 plus 10x. And then final step to get y by itself, just divide by 2. So y equals, we normally write the x term first, so I would write 10x plus 5 divided by 2. And we're done. I think we saw one exactly like number 10 in a quiz or something. We've seen this somewhere before. Here we need to notice that we've got 2 t values and they're being added together. So this is where we're going to do that opposite of distribution, which is called factoring. So that step looks like this. If I factor out a t, we would end up with a plus b. So remember, this is the opposite of distributing, because if we were to distribute that t, we would end up with what we originally started with. Final step, if I'm trying to get t by itself, remember that this is just multiplied, so that's t times all of that stuff. So if we divide by a plus b, we get t equals d over a plus b. Next, this is another problem we saw on a previous quiz or test. I forget which one. So we bought 2 boxes of markers and 1 box of glue sticks. We know how much the glue sticks cost. The total was $54.95. And our question is, how much did 1 box of markers cost? So we could think about this really generally. 2 boxes of markers plus 1 box of glue sticks, and so I'll just use m and g to represent those variables. That's going to be our total, right? So 2 times whatever the price of the markers are plus 1 times whatever this price is. Add it all up, we'll get our total. And we know the cost of the glue stick was this. So 2m plus $14.97 equals our total, $54.95. So then we just solve this as we normally would. Subtract $14.95 from both sides. And then we would, actually here, I was going to go through this a little more quickly, but I know this is a place where a lot of students made a mistake last time. So we would end up with 2m equals $40. So a lot of in the previous quiz, a lot of students said, well, a box of markers must be $40, but that's for the price of 2 markers. We would still need to divide that by 2 in order to get the cost of the markers. So 1 box of markers is $20. So now we know how much both of them cost, and it's telling us if we bought 8 markers and 2 glue, what's our total cost? So 8 times 20 plus 2 times $14.97, and I just realized that I made a mistake up above. This was not $14.95, it was $14.97. So this is going to work out slightly differently. It's going to give us some change, which is not quite as nice. Let me just go back and fix that real quick. So $54.95 minus $14.97 instead gives us $39.98. So when we divide that by 2, we end up with $19.99. So we were off by a penny. And let's change that here as well. All right, here we go. Now we can just punch this into our calculator. Plus 2 times 1497 is $189.86 for a total. All right, so that's the end of chapter 1. As we move into inequalities, this is chapter 2. It's really a lot of the same ideas. The solving parts are going to be exactly the same. We're just dealing with inequalities. Question 1 is write the inequality. So the sum, remember sum means addition, of some number y and 9 is greater than negative 1. So y plus 9 is greater than negative 1. So we're just translating from the sentence into the mathematical notation. So again, solving this is exactly like we did before. So if I'm trying to get x by itself, I'm just going to subtract 10 from both sides. X is greater than or equal to negative 4. Nothing to change the sign or anything there. Remember, the only time we're going to flip that sign is when we multiply or divide by a negative, which we're going to do here in about 5 seconds. Number 14. Right now we've got x divided by negative 5. So we need to multiply both sides by negative 5 to undo that division. And now since we're multiplying by a negative number, we need to flip the sign. So x is greater than 5, because negative 1 times negative 5 is positive 5. Moving on, we've got variables on both sides. Let's get all the variables to one side, all the numbers to the other. You could do this either way, but I'm choosing subtract the 4x so that my x values stay positive. Now add 20 to both sides. 2x is less than positive 12. Divide both sides by 2. X is less than 6. Next, again, same as before, we've just got a little distribution involved. So distribute the 1/3. So 1/3 times 12 would be 4 minus 3x greater than or equal to negative 2. Subtract 4 from both sides. We get negative 3x is greater than or equal to negative 6. Divide by negative 3, because that's what's being multiplied by the x. And we end up with x is less than or equal to 2. And again, since we're dividing by a negative, we have to flip that sign. I just also realized, I was thinking, oh, should we be graphing these? Yes, we should. So I'm just going to go back and I'm going to do the top 2, and I'm not going to graph the rest of all of these. But I expect that you can do that with a model of just a couple here. So remember, we're just going to draw our line. Our number is negative 4. Our x values are all greater than or equal to. So remember, the open side of that inequality sign is towards the x, so that tells me that x is the bigger number. So if x is always bigger than or equal to negative 4, the larger numbers are to the right, so that's where we're going to shade. And since it's or equal to, we've got a closed circle on that negative 4, and then we're shading everything to the right. Remember, what we're graphing is the x values. Those are the values that make this inequality true. Let's go down and do 15, because this will be a little bit different. So for 15, if we've got our line here, and x in this case is less than 6. So our number is 6, and x is all of the values smaller than 6. Since x is on the small side of that inequality symbol, but not equal to, that means we've got an open circle, and we're going to shade everything over here. Okay, that red line would represent all of those x values less than but not equal to 6. All right, and let's keep going. I've got all my x values on the same side. We just need to combine them. So we've got 8 is greater than. So let's do that combining right now. I've got a 6x and a positive 4x, so that's 10x minus 2. Add 2 to both sides. Divide both sides by 10. And we would read this as 1 is greater than x. And when I graph it, I always like to think from the x term, right? Because that's what we're actually graphing is those x values. So x is less than, because it's on the smaller side of this symbol, x is less than 1. So I said I was only going to do 2, but I'll do one more. So if there's 1, x is all of those values less than, but not equal to 1. And finally, if we have the double inequality, that means everything I do to one section of this inequality, I've got to do to all 3. So subtract 9, got to do it in all 3 places. So negative 12 minus 9 is going to be negative 21. Less than, I'm trying to go too fast right now, less than or equal to 3x, which is less than or equal to negative 15. And again, I'm going to divide this by 3 to get x all by itself, and if I do that to one term, I have to do all of them. I don't know why I put a negative there. So this would be negative 7 less than or equal to x, which is less than or equal to negative 5. And if we graph this, I've got 2 numbers now. I've got negative 7 as the smaller of these 2 and negative 5 as the other. And x is between them, right? It's bigger than the negative 7 and it's smaller than the negative 5. So that's everything in between those numbers or equal to those. So our graph of this would look like that. All right, number 19. Pair of wireless headphones cost $125. Chewy has $40 and plans to save $15 each month. Write an inequality. So in order to get the headphones, he has to have at least $125. So what we're looking for is we need to have, let's not say save. Let's say we need our money that we have to be greater than or equal to 125. Because when it is, then we can buy the headphones. So what represents how much money we have? That's this over here. I have 40, and I'm going to save $15 each month. So my money is $40 plus $15 each month. I'll just use the variable m for that. It's greater than or equal to 125. Okay, so every month we're going to save $15. So just kind of thinking about what this means. So when we have 1 month, we would have 40 plus 15. When we have 2 months, that'd be 40 plus 15 plus another 15. We can just solve this equation or inequality as we would solve any other inequality. Subtract 40 from both sides. And I'm going to run out of room, so let's actually just shift this over and then we'll kind of go like this. So 15m equals, not equals, is greater than or equal to $85. Divide both sides by 15. And 85 divided by 15 is, need m to be greater than or equal to 5.6 repeating. So it's going to take us 5 point something months. If we're talking about months, we usually think of that as whole months. So it would take us 6 months of saving in order to get those headphones. It takes 6 months to, let's just say, to save up. And I just realized that I wasn't looking ahead, and I went and I did the whole problem, solve the inequality and describe the number of months. And that's what we just did. Okay, so what you would really just need to do for part A is, all it asks you to do is this, just write the equation for inequality. Number 20, which of the following represents a function? Remember, function means that each x goes to exactly one y. So if we look at this, we notice right away I've got an x of -2, which goes to 5, and an x of -2 that goes to -2. So this is not a function. Here, I've got 4 unique x values, so we're good there. It just says to circle them, so that's fine. These next two are graphs, so we're going to use that vertical line test. And the first one does not pass because I can draw a line that will go through it twice, so that's a no. And here, no matter where I draw a vertical line, it will never cross twice, so this is a yes. 21, this is one that we struggled with a lot. So this is someplace where you should probably be doing a little extra practice and making sure you're paying attention. So domain is all of the possible x values. So I always think of this as looking, if I trace this going left to right, what values are included? We could have all x values included. Okay, going left, this is going to continue going down and left forever, down and right forever. So just left to right, we can have any value here. All real numbers. Range is all of the possible y values. So going from top to bottom, which y values can we have? And we notice that this is as high as the graph goes. It's going to go down forever and ever, but the highest value is here. And the y value of this coordinate is 1. So we can have y values of 1 and then anything less than that. So our range is all y values less than or equal to 1. X-intercepts, where it crosses the x-axis, y-intercept where it crosses the y-axis. So here's our x-axis. It crosses at -2, 0 and 0, 0. And where does it cross the y-axis? Also at 0, 0. So notice that a point can be an x-intercept and a y-intercept if it crosses the graph at 0, 0. Okay, these are the ones that we really struggle with. When is the graph positive and negative? So positive means above the x-axis. So where is this graph above the x-axis? From here to here. And we give this in terms of the x values. So for all x values greater than -2 and less than 0. Okay, it wouldn't be or equal to because on the line doesn't count as positive. So we would want to write like this. So I've got all x values greater than -2 and less than or equal, whoops, I just said not equal to, less than 0. And when is the graph negative? So that's where it's below the x-axis. And that's everywhere here. So all x values less than -2 and all x values greater than 0. So x is less than -2 and x is greater than 0. Finally, increasing and decreasing. So as we trace the graph from left to right, we want to think about when is that graph going up and when is that going down. So from here, notice that as I trace from left to right, I'm going up. As soon as I hit this point right here, it stops. This is kind of the turning point. We call this an inflection point. Now, from here on, it's going down. Okay? Right at that point, it's doing neither. Okay, so we don't want to include that point. So for all x values less than -1, we're going to be increasing. For all x values greater than -1, we're going to be decreasing. X is less than -1. Decreasing where x is greater than -1. And finally, end behavior. So you're going to be looking at the arrows here, like what is it doing on the left end? It's going down and it's going left. On the right end, it's going down and it's going right. If you even just said that would let me know that you at least understand what it's asking you to do. Our ideal answer, we're going to talk about those as x values and y values. So on the left end, it's going down, which would be decreasing y values. So y values are going all the way down forever and ever to -infinity, and the x values are going left forever and ever and ever to -infinity. So x goes to -infinity, y also goes to -infinity. On the right, again, we said it's going down, which would be y values getting smaller and smaller, and it's going right, which would be x values getting bigger and bigger. So in a perfect world, we're going to say that x is going to +infinity and y is going to -infinity. All right, final page, final couple questions. Profit from selling coffee is represented by y equals 4x. So x is the number of coffees sold, y is the profit. Never a bad idea to just label your axes, right? This is our y-axis, this is profit, this is number of coffees, and this is our x-axis. So part A says to graph the equation. Our equation is y equals 4x. X could be, if we're thinking about this being coffees, it can be any number bigger than 0 or bigger, right? We could sell 0 coffees, 1 coffee, 2 coffees, 3 coffees. It's also going to be a discrete domain, right? Because it doesn't make sense to sell 1.25 coffees. So let's think about some x values that we could plug in and then see what the resulting y values would be. So again, I'm just going to rewrite our equation, y equals 4x. And I'm just going to make ourselves a little table here to help us think about some points that would be on this graph. If this is a linear equation, we really only need 2 because we're going to make a straight line. But I'm just going to plug in a couple more than that just to help us kind of maybe visualize this a little bit more and think about what's going on. So if x is 1, so if we sold 1 coffee, that means we're plugging in 1 for x, and y is 4 times x. So 4 times 1 is just 4. If x is 2, 2 times 4 is 8. If x is 3, 4 times 3 is 12. And we could plug in any of those numbers that make sense for our situation. So let's just plot those couple of points. So when x is 1, y is 4, that's here. When x is 2, y is 8, that's here, here. And our graph should, let me just plot those couple points and then draw a line. Should look like this. Although we said that this part isn't really going to make sense, right? Because we're not going to sell negative coffees. But if we're just drawing the line, that's what the line would look like. Actually, I'm going to get rid of this over here because that really doesn't make sense. Okay, what would be the profit for 5 coffees? Now, we could just plug in 5 for x and do 5 times 4 gives us 20. Or since we've done the graph, we can look at when x is 5, what is y? 20. And this is profit, so that would be $20, because it says our profit is in dollars. Part C, how many coffees will be sold if the business profit is 32? So remember, profit is that Y value, so what we're really doing here is we're plugging in 32 for Y. So if Y is 32, what is X? And this is just a one-step equation where we divide both sides by 4, and you get X is 8, which is the number of coffees. Okay? So how many coffees will be sold? We should technically write our answer like that. What are the independent and dependent variables? So independent is our X value. Our dependent is our Y value. So independent is X, or number of coffees, and dependent, which is our outputs, this is our Y values, which is profit. There we go. Final couple questions here. Same idea, we're just using function notation. So here's our equation, and f of 2. So remember, that is our x value. So what we're looking for is, what is the y value, or what is f of 2? So that means we're going to plug in 2 for x, and then we are going to simplify. So f of negative 2 is 4 times negative 2 minus 12, which is negative 8 minus 12, which is negative 20. So when x is negative 2, f of negative 2 is negative 20. Or remember, f of x is the same thing as y if we're thinking about it as like a graph. The point on this graph would be negative 2 comma negative 20. Next, f of 0. So that's still an x value that we're plugging in. F of 0 is 4 times 0 minus 12. This works out really nice because so anything times 0 is just 0. So f of 0 is negative 12. Next, final ones. It's telling us f of x is negative 4. So that means I'm going to plug that negative 4 not in for x, but instead of f of x. And it tells us I'm looking for the value of x. So make sure that you understand, in these types of problems, we've struggled a little bit determining where we're plugging in. Right? And this tells us that f of x is negative 4, not x is negative 4. So it should look like this. Negative 4 equals 4x. Getting a little sloppy here, sorry about that. 4x minus 12. And we're just going to solve for x. Add 12 to both sides. This is going to give us 8 is equal to 4x. Divide both sides by 4. X is 2. Final one, f of x is equal to 6. 6 equals 4x minus 12. Same steps as before. Add 12 to both sides. 18 equals 4x. 18 divided by 4 is 4.5. X equals 4.5. And if we're thinking about this in function notation, now we've found our x value, so we could say f of 4.5 is 6. We've now found that value of x, so that f of x is 6.